If you want to find the area of a shape like a square or a rectangle, the process is simple. You measure the straight sides and multiply the base by the height. But as soon as a shape has no straight edges, like a circle, traditional measuring tools hit a wall. The rigid lines of a grid leave messy gaps and overlaps around the curves. When you cannot measure a shape directly, there is a reliable mathematical workaround. You change it into a shape you already know how to measure. Understanding how to measure a circle comes down to a shift in how we look at its shape. This works because shapes can be taken apart and put back together in new ways. They are more like puzzles than solid, unchangeable blocks. Take a look at this physical model. It is a solid, circular object sitting perfectly flat, and it will serve as the starting point for our puzzle. To figure out the area of this entire circle, we first have to break it down into manageable pieces. The first step is to slice the circle evenly, starting from the center and cutting out to the edge. This creates a series of distinct, identical wedges. Now for the reassembly. We take those identical wedges and line them up, alternating them head to tail, so one points up and the next points down. When the wedges interlock like a track, they form a new shape. As you can see, it closely resembles a long, bumpy rectangle. We haven't added or removed any material during this process. This new bumpy shape contains the same area as the original circle. However, because the outer edges of our original wedges are curved, the top and bottom of this new track are still jagged. Standard rectangle formulas won't work perfectly on it just yet. We have transformed the shape into something closer to a rectangle, but we need a theoretical trick to iron out those remaining curves. This diagram illustrates our next step. It shows a flat circle divided into a few wedges, unrolling into our bumpy rectangle shape. What happens to this shape if we cut the original circle into smaller, much thinner wedges? A geometric pattern emerges. As the number of slices increases, the jagged bumps on the top and bottom get flatter, and the slanted sides stand up straighter. Now imagine taking this process to infinity, cutting the circle into an endless number of microscopically thin slices. At infinite slices, the bumps disappear completely. The slanted edges become perfectly vertical. By pushing our slices to infinity, we have successfully shape-shifted an impossible curved circle into a perfect, easily measurable rectangle. This diagram shows a side-by-side comparison of our original circle and our newly formed perfect rectangle. The vertical height of the rectangle is made from the straight edge of just one sliced wedge, the distance from the center to the edge, the radius, or r. Next, we find the base. The top and bottom edges of the rectangle are made entirely from the curved outside boundary of the original circle, the circumference. Because half the wedges point down, the bottom base is exactly half the total circumference. We can translate this directly into math. The formula for the total circumference of a circle is 2 times pi times r. Cutting that in half leaves us with a base length of simply pi times r. The rectangle's dimensions are now defined by the familiar traits of the circle. The height is r, and the base is pi times r. Now we apply the standard rectangle formula to our new shape. We calculate the area by multiplying the base by the height. When we multiply pi times r by our height of r, we find the area of the rectangle. This formula, pi r squared, describes a rectangle hidden inside the circle. Solving a complex problem often means rearranging the pieces until the solution becomes clear.